Hello, my name is Peter Koch. I'm Global Application Engineer at the company Yxlon International in Hamburg. Today I want to show you how to run a CT and to do failure analysis on a CT volume. Because CT, if you have a small sample, it's very important for failure analysis because you can see failures or explain failures which you can't do in a regular 2D inspection. For this I have prepared two samples here. One is a blown bond wire. This you can see also in 2D, but for the first sample it's easy to use and it's easy to explain what I'm doing with the CT volume, how to do the visualization, how to set up the reconstruction with all the algorithm and so on. The next one is a package on package with a head and pillow. This is very difficult to see in 2D, and so we are using CT for detecting the head and pillow on this sample here. So I placed these two samples at first into the X-ray system to show you what we are looking for. After closing the door, our software creates an optical overview with the two samples here on the rotation tray. If I click on this sample, automatically it moves to this position and starts the X-rays. So we have here our component. And as I said before, normally you don't need a CT for this, but it's very easy and very useful to explain this on an easy sample, what I am doing later with CT. So if I magnify, just draw a rectangle, and then we can see here that we have a blown wire. Also here is a damage of the wire. This with the package on package. So you see here, if you look for a failure on a package on package, it's very difficult because you have to rotate all the time, you have to modify the magnification, so it's really very difficult. And if you have a small sample, it's very comfortable to use CT because you have the complete package on package in one volume, and you can slice through the sample, you can create clipping planes, you can rotate and everything what you want to do to find the failure. Then I open the door. For CT we have to stick the samples on a sample holder like this one here. So we have two different kinds of sample holders. This I want to show you. Number one are only sticks. This is very useful for smaller samples. So just fix it here on the top of the stick. So it's a very good, so you can reduce artifacts here. If you have bigger samples, you can use sample holders like this one here. It's very easy to mount, just use hot glue, that's it. You can remove it very easily later after the CT acquisition. For a high quality CT, we need a high quality tube. In our case, we are using a high resolution tube from Yxlon. Our Oryx detector is brand new. We have a very big field of view now. We have a very good electronics inside, which is more radiation resistant, and our electronics is designed to get a high quality image, and also the speed of the acquisition is very fast now with this new Oryx detector. I start here. We have selected Micro CT. We have selected our software for the reconstruction and visualization. We start with a quick scan. Quality scan is you have an integration of up to 5, up to 10 frames per image. In this case I have an integration of only one, so there is no integration, but it's quicker. Next step is I switch on the X-rays. So we have here our component with a broken wire. I can change or play with the magnification to get a better result. So like this one here. To check if our region of interest is still in the field of view during the rotation, I can test it. Just rotate around 360 degrees and you see our sample is always in the field of view. So you can't miss anything. Histogram is also okay. Next step, numbers of steps. I have set it to 2000. We have the full rotation with 360 degrees. Cube size is 1276, and we have different settings here for the reconstruction, and we start automatically the reconstruction when the acquisition is completed. Then we give a name. Okay. And then we click on play. And then the acquisition starts, and automatically the reconstruction on the CT-PC will start also. After the reconstruction, I have selected my visualization here. So I have 3 screens for X, Y, and Z, depending on your alignment of the volume. And here we have the CT view. What we have seen in the 2D inspection, we have a blown wire. It must be somewhere here. Again, we have here green screen frame around the screen, and we have here the green axis. I can move the axis up and down. So the blown wire must be somewhere here. I can magnify it. And you see we have a small bubble here, a small bubble here, and so on. I can improve this quality by using thick MAXIP, maximum intensity projection. And you see here that we have a disconnection from the wedge to the ball bond. Also we have a small bubble here from this wire. I'll make it a little bit better. Then we can set the brightness also, or modify the brightness like this one. So after this is completed, I want to start with the CT view. For this material, I select materials, set the shininess to maximum. It's not necessary, but it looks a little bit better. For the transfer functions, which are presets for colors, for the histogram, and so on, I select Bronze 2 in my case, and it's only one click. You have a nice image here. Also, I switch back to full screen, and we have here the correct wire, which is not blown. We have the blown wire here. Here are small bubbles, and also we have a damage here on the ball bond of the other wire bond. Here's the rest of the ball bond from the blown wire. Next is, because we have only a small region of interest, you see it, you can remove everything what you don't want to see in your region of interest. So you can use here the clipping box. It's really a box around your volume. So, and with shift control, just move it a little bit and remove everything what's not looking so good. So here and maybe here a little bit. And also you see from the visualization and everything, we have only a few buttons. This is what you need really. Next step is I select again a new renderer, the cinematic renderer. I select another transfer function. I make the range smaller. So it's more a realistic view. Like this one here. So the cinematic renderer is working with a lot of shadows, and it's really a realistic view to your sample. Let's select another transfer function like this one here. And you see it's only one click. If you have prepared your transfer functions, if you have a good region of interest for your sample, this is what your manager wants to see. He wants to see a good image which explains everything. It's easy to use. You can zoom in. And then you can see the blown wire here. Here's the rest of the ball bond also here. After the reconstruction, we will have our visualization. We have again X, Y, Z, depending on your alignment of the volume. And we have here the CT view. I can slice through my volume. You can see here already we have the head and pillow here. if I move it to this position. And use my thick MagZip. We have here all the balls are failed because you see we have a small gap here. The small gap. It's also possible to see this shape of the balls with luminography, but with luminography with a lower resolution you can't see the gap here. Also here, if you switch back to the CT view, I have marked these balls here to select it also here, and the CT view. From the shape of the balls, you see there's no connection. So if I switch on full screen, I can modify a little bit my transfer function to reduce all the noise. Just move it a little bit to the side, like this one here. And it takes only a few minutes, 2 minutes, to get a result like this one here. So we have all the balls here are failures because of the head and pillow. Then we start again with my cinematic renderer to get a more realistic view in the volume. It's just one click. Select cinematic renderer. You have already one transfer function selected. You can change it if you want, or you can create a new one like this one here. You can use colors, it's up to you, like this one here. You can zoom in. You have the shadow here again. You have a nice shape of the balls. Rendering takes a little bit because all the volume has to be rendered at the same time. But also if you don't have any experience and someone explains to you, okay, head and pillow is looking like this one here, everyone could understand it. You can move it, you can rotate it, whatever you want. I select another transfer function. So we can create also a volume with our Y colors, like this one here. So I move it a little bit. In the last volume I have used the clipping box to reduce all features I don't want to see, like this one here. But we can create also a inverted clipping box. In the beginning the clipping box is very big, but you have to minimize it. This is what I'm doing now. Just move it, just make it smaller, nothing else. So I have my clipping box, and then I can cut with this inverted clipping box into my package on package. Might make it a little bit bigger to this balls here. This one, so, and then you can have a look inside this BGA balls. So it's cut it out of the package on package, and you see also inside the BGA balls you can see that we have a gap here. I hope you have understood a little bit what I have shown to you. You see the visualization is very easy, the software is easy to use, the quality is excellent, and you can't find a quality like this one in the electronics market. Thank you.